We're going to try this one more time. My microphone did stop working for number 10, so I'm going to start with number 10 on the second video. We did expect you for this question to use your technology. Essentially, you wanted to graph each of the functions of the system and figure out which one has exactly one intersection, because again, we're looking for the system that has exactly one solution. So technology-wise, in Desmos, you're looking for the system that intersects each other exactly once. If you do that correctly, you should get C. Here's a graph for C, and you can see here that it crosses in exactly one place, which is right there. Doesn't matter where it is, we just want you to visually see that it intersects once, which means there's one real solution for that system. All right, here we're looking at systems of inequalities. Craft toy wagons are made to sell at a craft fair. It takes 4 hours to make small wagons. It takes 6 hours to make large wagons, which we're calling Y. Small wagons are X, large wagons are Y. The craft booth owner has no more than, this is really important, no more than 60 hours available to make them. And also important, we want to have at least 6 small wagons. So we need to write our inequalities first, which the lines themselves are graphed for you, but we need to figure out where they are shaded. So let's look at the hour constraint first. Again, X is small wagons, Y is large. It takes 4 hours to make a small wagon. It takes 6 hours to make a large wagon, and altogether we want that to be less than or equal to 60 hours because we do not have any more than 60, or the craft booth owner does not have any more than 60 hours to spend making them. Additionally, we want at least 6 small wagons. So we want X to be greater than or equal to 6. Again, at least means 6 or higher. No more than means 60 or less. So make sure those inequality symbols are correct. Now, with regards to our shading, for the first constraint, that 4x plus 6y is less than or equal to 60, that is this slanted line right here. Already graphed for you, but we need to shade it correctly. We want it to be less than or equal to 60, so we're going to shade below that line. Sorry, my pen is being a little laggy today. All right, we also want X to be greater than or equal to 6. That is this line right here. There's X equals 6. We want it to be greater than, so we're going to shade to the right. All right, now we're looking for where the colors intersect, where the shaded regions intersect. That is where all of our possible solutions are. That's going to occur in this triangle right here. Remember, the feasible region is either on the region or inside it. Okay, so the question is asking which of the following is a possible combination given the constraints. Be very, very, very careful here. Notice that they're listing large wagons first and small second. We made large Y and we made small X. So when we write the coordinates to see where we're looking, we need to make sure we write it correctly. So for A, if we look at it as a coordinate, as a solution, that would be 2 small and 0 large. B would be 2 small and 1 large. C would be 8 small and 4 large. And D would be 6 small and 8 large. Now we have them written correctly, we can figure out which one lies in or on the constraint. So if we take a look here, 2, 0, not in the region. 2, 1, not in the region. 8, 4 is in the region. All right, 8, 4 is somewhere right here. All right, it is inside our feasible region, so our answer is C. If he makes 8 small wagons and 4 large wagons, it fits both constraints that we determined of this scenario. Now the second part to this is how we can maximize profit. Remember, maximizing and minimizing occur at one of the vertices of the feasible region. So you have go back here. You have 3 vertices because we've got a triangle that represents our feasible region. You've got a vertex right here. You've got one right here. and you also have one right here. All right, if we list those out, those vertices are at 6, 0. What else did I say? 6, 6 and 15, 0. Now, if we want to maximize profit, and the profit equation is given to us, which is right here, that the profit for the number of small and large wagons is given by 12x plus 18y. We want to plug in each of these coordinates, each of these values for x and y into our profit function to see which one is the highest, because we're looking for maximum profit. So if I plug in x is 6 and y is 0 for the first one, I've got 12 times 6 plus 18 times 0. That's going to give me a total profit of $72 if I make 6 small wagons and no large wagons. If I make 6 of both, that's going to give me 12 times 6 plus 18 times 6, which gives me $180. So much better scenario. And guys, I'm sorry for my writing. My pen is lagging really bad. I think it has to do with the storm that's going on right now. I'm not quite sure. Hopefully you can read it okay. If I do 15 small and no large, that would be 12 times 15 plus 18 times 0. That's also going to give me $180. Regardless, if I say what is the maximum profit between 72 and the two 180s, my maximum profit is $180. Wow, that looks absolutely horrible. So sorry, guys. I'm not sure what's going on here. Let's try this one more time. $180. Let's look at sampling methods and which one is more accurate. In this case, an upcoming rapper wants to see what people who downloaded his last album, think about his songs, which would provide the best sample. So really what you're asking here is which option is least biased, which one is going to give him the most accurate sample. If we look at a random selection of people ages 15 to 25 who downloaded the album, we clearly have bias here because you're only looking at people ages 15 to 25. The younger generation is probably going to have a different opinion about a rapper than the older generation. B, randomly selecting 125 girls and 125 boys who downloaded the album. This is actually a stratified scenario because you are randomly splitting them into two groups and then drawing from the same amount randomly from each group. All right, so we'll get back to whether or not that's the most accurate in a second. C is 250 girls who downloaded the album. Problem here, again, you've got bias. You're only asking girls. And last one, a random selection of 250 people who downloaded the album. So this is basically taking the complete roster of people who downloaded it and randomly selecting 250. This is an example of a simple random sample. As we learned in class, unless there's a lot of bias, simple random sampling is the most accurate way to collect your data. So the answer for this one should be D. Moving on to normal distribution questions. SAT math scores are normally distributed with a mean of 450 and a standard deviation of 110. We want to determine three different things here. First of all, what percent of the scores lie between 450 and 270? Now, if you look at these two scores that are our bounds, and then you compare them to the curve that I already created using the mean and standard deviation, remember mean is down the middle, we add the standard deviation of 110 over and over again 3 times to get the standard deviations to the right of the mean, and then we subtract 110 to get the standard deviations to the left of the mean. So I've already built a curve for you. If you look at these numbers on the bottom of the curve, none of them are, well, 450 is one of them, but 570 is not. So because 570 is not included as one of those numbers under the curve, we need to use our calculator for this. In fact, if you look at all of these, 490 is not on the bottom of the curve, neither is 520. So we're going to use the calculator for all of these. Remember, guys, this is where you go to second vars on your calculator. Then you're going to choose number 2 for normal CDF, and then you're going to fill in the values that it asks you for. And those values are the lower bound, the upper bound, the mean, and the standard deviation. So let's take a look at the first one. We want the percent of scores that are between 450 and 570. In this case, our lower bound is 450. Our upper bound is 570. Our mean was given as 450 and our standard deviation was given as 110. These two values, the mean and standard deviation, they're not going to change for the other examples, so I will not write them again, but we will use 450 and 110 for the remaining two as well. All right, so if you put these four values in your calculator correctly by going to second vars, the number 2, as I stated before, you should get for A that the probability or the percent of scores that lie between 450 and 570 is 0.362. All right, we're going to do the same thing. Now this time we want no more than 490. All right, no more than 490 means 490 or less. All right, so this is important when we're making our bounds. That means 490 is the upper bound, and then something really small is the lower bound, which we said make negative a million. So when you're setting your bounds for this example, your lower bound should be negative a million. Your upper bound should be the 490. And then of course our mean and standard deviation are still 450 and 110. Putting those into your calculator, you get 0.642. 64.2% of scores are no higher than 490. And then the last one, we want to determine what percent of the scores are at least 520. At least 520 means 520 or higher. That means now 520 is our lower bound. So our lower bound here is 520. Our upper bound is, now we want it to be higher, which we're just going to say is a million. Putting those into the calculator using the same steps, you get 0.262. All right, guys, in this particular question, we're trying to find the function that has a domain of x is greater than or equal to 2 and a range of y is greater than or equal to 7. Now notice that all four of these functions are different. This is an absolute value, this is a square root, this is a cubed function, and this is a log function. So again, our intent is that you're using your technology to answer this question. Now, similar to before, I'm not going to show you all the graphs, but if you were to graph all of these in Desmos, all right, the answer to this question is going to be B. All right, I'm going to explain why. We can look at some of the other choices individually if you have questions. But when I graphed A, I realized, first of all, it was an absolute value function, which is that V-shaped function. So with absolute value functions, the range is restricted, but not the domain. So the domain of all absolute value functions is all real numbers. So for that reason, it's not A, because we want our domain to be x is greater than or equal to 2. I'll come back to B in a second. C is a cubed function, which is our little S curve. All right, we know that for cube functions, the domain and the range is always all real numbers, no matter what kind of cube function it is. And then, so automatically that takes it out of the running as well, because we want our domain and range to be something other than all real numbers. Log functions have a domain that is restricted, but the range is always, for log functions, the range is always all real numbers. All right, so again, we want our range to be constrained, so it's not going to be D either. If you remember all these, you could pick B without using technology, but let's look at the graph. Here's the graph for B, the square root function. Remember, square root functions have that end point and then an arrow on the other end. This end point right here is at 2, 7. All right, if you sort of draw a little vertical line down that point, let's talk about our domain. All of my graph is to the right of that x value. That x value is 2. So that means my domain is x is greater than or equal to 2. So far so good. Then if we look with sort of horizontally, all right, All of our graph is above that y value. All of my graph is above that y value, and that y value is 7, which means that my y's are greater than or equal to 7. Again, exactly what we wanted. So for that reason, B is the choice. All right, guys, there's two different ways to solve this. I'm going to do both just to give you guys some variety, and you choose which one you like. I have a tendency of rewriting equations so that I don't have to convert if I can. I saw that I can rewrite this equation as 5 to the x plus 7 equals 5 to the negative 2. So basically what I did is I rewrote this 1 over 25 as 5 to the negative 2, because remember that negative is what puts that 25 on the bottom. Now, the reason I did that is because now the bases are the same. So I don't have to convert, and all I have to make sure is that x plus 7 is equal to negative 2. So then when I subtract 7 from both sides, I get that x is equal to negative 9. So that's one way to do it. The other way is to go ahead and convert. So we're starting here. Let's say I don't realize that I can rewrite it. The exponential is already isolated. I can go ahead and convert. I'm going to start at the base of 5 and go towards my equal sign. So it's going to be 5 raised to the 1 over 25 equals x plus 7. Again, that's 5, sorry, not 5 raised to, log base 5 of 1 over 25 equals x plus 7. So we've got log base 5 of 1 over 25 equals x plus 7. Now this right here, you've got to use change of base for. All right, so in your calculator, you're going to be doing log of 1 over 25 divided by log of 5. All right, when you put that in your calculator, it should tell you that that's negative 2. So what you end up with is negative 2 equals x plus 7, which is where I was right here. It just, to me, took a little longer, but you get the same result. So I'm going to subtract 7 from both sides, and again, I get that x is equal to negative 9. All right, so either way, you get x is equal to negative 9. All right, which of the following statements are true about this graph? First of all, this is an exponential. Keep that in mind. It's got that y, that horizontal asymptote at y equals negative 1. All right, it is not flattening vertically, only horizontally. So let's look at A. We're choosing all that are true. The y-intercept is positive 3. That is true. That is crossing the y-axis at 3. So that was good. The x-intercept is 2. That is not true. It's actually crossing right here at 1, not at 2. So it is not B. C, the asymptote is y equals negative 1. We just showed that before. That is true. We've got a horizontal asymptote here at y equals negative 1, so that one is true. Range is all real numbers. That one is false. Remember, because of this horizontal asymptote, it's restricting the range. I have nothing down here. All of my values, all of my graph is above y equals negative 1. It is not all real numbers, so it is not D. E, the domain is all real numbers. That is true, and that's true for any exponential, all right? There is no vertical asymptote that's restricting the domain. I can have any value from negative infinity to positive infinity. F of x is positive for all values less than 1. Here is 1. Here's x equals 1. All values less than 1 is all the graph from there to the left. If you look at this piece of the graph, all of that is above the x-axis, so all of that is positive. All those y values are positive. All right, so that is also true. And then last one, as x increases. Another way of saying that is as x approaches infinity. My f of x approaches but never reaches negative 1, so it's saying my f of x is approaching negative 1. Well, let's look at that. So as I go right, as my x's are getting bigger, my y's are, yes, in fact, approaching that asymptote at negative 1, so that is also a true statement. In this case, you have 5 true statements. All right, guys, another technology question here. We want to find which of these equations has no solutions. In other words, in Desmos, when I graph them, they do not intersect, no intersections. All right, so we expect you to graph each one of these until you find one that intersects not at all, does not intersect at all, because we're looking for no solutions. All right, when you go through these graphs, it turns out that B When you graph the square root of negative 14x plus 2 equals x minus 3, when you graph them, you should see that they do not intersect. So I included that graph here just for you to visually see. You can see that they do not cross at all. You do want to make sure that you zoom out or zoom in enough to make sure you can see all the intersections if there are any. In this case, there are none. All right, we are trying to find an equivalent expression for the one given. Now look at your choices. All of them are solved for b, so that's your clue that you need to solve for b in this equation. So we're starting with y equals c times log base 4 of ab plus 10. We want to solve for b, which means everything else needs to go to the other side so I can convert this log and eventually solve for b. So I'm going to subtract 10 first. Always move by addition or subtraction first. That gives me y minus 10 equals c times log base 4 of AB. Now I need to move that c. The c is being multiplied by that log, so we're going to divide the entire side by c on both sides. So now I've got y minus 10 over c equals log base 4 of AB. Now I can convert my log to an exponential so I can get into that parenthesis and solve for b. So starting with the base, going towards the equal sign. 4 raised to all of this, so raised to the y minus 10 over c equals AB. Remember, this travels together. So again, that's 4 raised to the y minus 10 over c equals AB. Last step is to divide by a on both sides. So I'm finally left with b equals 4 raised to the y minus 10 over c all over a, which is b. All right, which statement is true about the graph below? First of all, look at its shape. Hopefully you can see that this is a cube root function. All right, so let's look at the statements. Which one is true? Domain is from 2 to infinity. That is going to be false. Cube root functions always have a domain of all real numbers. If you look, this side goes all the way to the left, this goes all the way to the right. There's no vertical asymptotes that are restricting the domain. I can have any x value from negative to positive infinity. So it's not A. B says as my x's increase, so as I go right, my y's are also increasing. So as I go right, my y's are going up. If you follow this graph, as I go right, my y's are actually going down, not going up. So it's not this one. See, as I go left, as my x's are getting smaller, my y's are also getting smaller. So as I go left, my y's are going down. So let's go the other way. As I go left, again, my y's are going up. They are not going down. So this one is also not correct. Last one, the range is all real numbers. That is always true for cube root functions. Answer is D. All right, 2 questions regarding this piecewise function. Remember, you need to make sure that the piece you're looking at represents the equation that you're looking at, and so that you're matching the constraints. All right, we're going to go from red to blue to green. And you got lucky if you look at the equations, that is how they go in the choices as well. All right, so let's look at the red piece first. This x value is -1. All of my graph is to the left of that piece, and I have an open circle here. So constraint-wise, this piece exists when x is less than -1. It's not less than or equal to because this is open. Now let's look at the blue. All right. This piece, closed on both ends, it is the U shape, so it's the squared piece. It exists between -1 and 2. I should have equal to on both ends of the compound inequality because both of those circles are closed. So its constraint is going to be that x is between -1 and 2. And then finally, the green piece, we've got a horizontal segment here that has a value of -1, and it has a value of -1 from 2, and then that segment is everything to the right of 2. That is an open circle, so x has to be, for that constraint anyway, x has to be greater than 2. So if we take a look at all of these constraints and we choose the one that matches it exactly, we get that C is the correct answer. Now, with respect to the average rate of change, there's two that we want to calculate. All right, if I look at the interval between -5 and -3, and for the sake of this, I'm just going to erase all of this now that we've used it to figure out the correct equation. That way I have room. If we look at the interval from -5 to -3, -5 is here, -3 is here. So we're basically looking at the average rate of change of that piece, which is that linear piece. That linear piece is y equals x. All right, so there's a couple of ways that we could do this. If we know the equation is y equals x, well, that's the slope-intercept form of the line. You have a 1 there that we just don't write. And remember, if it's in this form, the m, the coefficient in front of the x, is your slope. So in this case, the slope is 1. All right, if you're going by the equation. Now you could also you could count. All right, I could count from this point right here to this point right here, or the other way. Let's just start left to right. So I have to go up 2, which is positive. I have to go right 2, which is also positive. If I do rise over run, I have 2 over 2, which is 1. So you still get 1 either way you do it. You also can pick 2 points, so I could plug those 2 points into the slope formula, which we're actually going to do for part B. So just as a reminder, since we're going to use it in a second, the slope is equal to y2 minus the change in your y's over the change in your x's if you have 2 points. We're going to use that for part B. But for part A, it's easy enough just to look at the equation. Or to count it as I did here, 2 divided by 2 is 1. Now for B, we're looking on the interval 0 to 2. So here's 0, here's 2. All right, so we're looking for the piece on this parabola between 0 and 2. Now for this one, because it is not linear, we have to use the equation. We have to use the equation for slope. So I'm going to use 2 good points, which this one is 0, 1. And then I'm going to use this point right here, which is on the end of that interval, which is at 2, 5. All right, I'm going to use that and put it into the slope formula. So my slope, the average slope, which is just an estimate, it's not a true slope because it's not linear, is going to be 5 minus 1 over 2 minus 0, which gives me 4 over 2, which gives me 2. So for part B, the average rate of change on that quadratic between 0 and 2 is 2. All right, we got another normal distribution question. The average height of women is 64 inches with a standard deviation of 3. So our mean is 64 and our standard deviation is 3. Assuming heights are normally distributed, what heights do 95% of women fall between? The fact that it said 95 should be a hint that you're using the curve and not the calculator. Remember, there are 3 big percentages you need to remember. 68% of the data lies between 1 standard deviation from the mean. 95% lies within 2 standard deviations from the mean, and 99.7% lies within 3 standard deviations of the mean. So since we want to know the values that 95% of the women fall between, we're looking for within 2 standard deviations from the mean. So what I did is I went ahead and built the numbers on the bottom of the curve. I didn't actually draw the curve. 64 is the middle, it's the mean. I added the standard deviation of 3 inches 3 different times to get the numbers to the right, and then I subtracted the standard deviation 3 times to get the numbers to the left. Since I want within 2 standard deviations of the mean to represent that 95%, here's 2 to the left, here's 2 to the right. So the values that represent 95% of women are between 58 and 70, which would be B. An oceanographer has determined a relationship between the wave height in feet relative to the wind speed in knots. The model of the relationship is below, which represents the domain of the relationship. So this is one where you have to look at the context of the question and relate it to the domain. You're given the graph. If we're talking about domain, we're looking for the x-axis of our relationship, the x values, which in this case is height. So if we're talking about domain, we have to be talking about it relative to the wave height, which means it can't be B and it can't be D. Those are relating it to wind speed, which is not on the x-axis. So the question is it from 0 to 10? or is our domain from 0 to infinity? I do want to point out, if you cannot see it clearly, that there is an arrow right here, which means this graph keeps on going. There are no values technically that we cannot have after 0, so for that reason we're going to say that our domain is from 0 to infinity. It is not from 0 to 10. If it were from 0 to 10, it would be stopping right here. There would be an endpoint. There would be no arrow right here. That arrow means it keeps on going. So our domain is from 0 to infinity.